Hello, my name is Frederik Steinmetz for BlenderDiplom.com,
And I'm Gottfried Hofman, also for BlenderDiplom.com.
and in this tutorial we'd like to show you how to bake normals in cycles. And if you want to know how to bake normals in Blender Internal, I'd ask you to watch the previous version, the link you'll find below this video. And let me start off by demonstrating how the normals look. For this I have prepared a couple of renderings. This here is the high poly object from which I want to bake. So this would be basically the original. If I switch to slot number 2, you can see this is the object I want to bake to. So it's basically the same object in the beginning, but there is a multi-resolution modifier on this one, and I took the liberty of sculpting a little dirt in here, and also if you compare this, there's some sort of ornament or something below the cross. And if I actually do apply the normal map, it'll look like this. You can see the differences right here. There's a big difference. And we get some artifacts over here because very big difference between those two. And you can immediately see the normal maps work very well when it comes to shading. Right here this dirt looks very good. It works very well as compared to the original, like this. But it does not change the outline, meaning this, let's call it a belt, will not be shown by the normal maps. This is the original again, and this is the normal map. And last but not least, there are two methods and cycles how to bake it. This is using a cage, and this is using no cage. And I'm going to explain all of this, including what a cage is, in a second. So let's get started. For this I prepared a cube, and by prepared of course I just mean I did not delete it. And let's see what we can do with that cube. I'm going to switch over to the UV editing for this, because there we have the UV editing window, meaning I can manage my UVs there, and I can also preview my image basically while I'm baking. But in order to have the bake button handy, I'm going to drag this out. I'm going to switch this to properties, and there under the render tab all the way down we have the bake option. I'm going to twirl this down, and you can see the bake option appears. Now in Blender Internal you need to unwrap your object and then assign the image you want to bake to the UVs by doing something like this. I'm going to create a new image and call it normal. And I'm going to leave the rest of it as the default settings, click OK, and then in Blender Internal it would automatically bake to that image. In Cycles it doesn't, so don't be confused by that. What we need to do is open up a node editor, because in Cycles the way you choose the texture is actually by creating a material. I'm going to press Shift A and add an image texture. And now I'm going to select the normal that I just created, and by clicking on this, Cycles will know this texture is where I'm going to bake whatever we choose here to. You can have multiple images in your material, and by clicking on one of them, like so, you activate the one you're baking to, which is very handy if you want to bake different channels to different images. I'm going to delete this one again and use this image. In order to bake, let's choose normal here already. In order to bake you need a UV layer. If I just click bake, it'll complain that there is no UV layer, and of course we need a UV layer because otherwise Cycles would not know where on the object a, let's say, object in 3D space would be projected to. And to demonstrate this kind of complicated sounding thing a little better, I'm just going to go ahead and do it. Now if I press U, I can choose between a number of options. If you're a pro, you're going to use unwrap, but for that we're going to have to put seams or set seams in our object, so I'm not going to use that. I'm going to use the lazy man's version, which is Smart UV Project. And if I click this, I'll just press OK, and you can see we have a very clean unwrap of the cube. Now let's have a look at the options. I'm going to start with the margin, and it says 16 pixels. If I'm just going to, let's select the diffuse again just to demonstrate this. Diffuse direct, and I'm going to bake this. We can see that this overlaps. The bake does not stay inside of the faces. So this is something we need to change, and I understand there are two different methods of solving this problem.
One of them is to use when you're using Smart UV Project. Just select it, and there is the island margin option. Just set it to a very low amount, like 0.1. And for the margin, go down from 16 pixels to 1 pixel, because you won't need it in cycles any much higher than 1 pixel. 16 pixels is just if you're doing for games, which we are not doing here right now. So if you're doing games, 16 pixel is fine, but for cycles you only need 1.
You're absolutely right there. In games, if you use a margin that's too low, errors can occur. There can be actual gaps in between the normals or in between the seams, and there hideous black lines can occur. But usually in cycles 1 pixel is more than enough, because cycles is not real time, so it has a lot more time to calculate all of these, and thereby it can do a much more precise job. And you can see right now, since I turned down the margin down to 1 pixel, there's only a tiny overlap, and we're fine. It's not overlapping with the faces anymore. So at this point you can choose either to reduce the margin or increase the island margin. Alright, so let's now switch this to normal baking, because this is what we're here for. And let's have a look at all the options. Clear, all that does is to erase your image before baking and making everything transparent, and then just writing the important parts of your image, meaning where your faces are, to the bake to image. Alright, if I press bake right now, I would get nothing. Even though there is the blue color right now, I'm still calling this nothing, because this is the neutral color, and parts of your texture where this color is present will not alter your surface. So basically this is still nothing. The reason why we don't get anything is because where should Blender know from in which way we want to displace the surface? What I can do is I'll add a monkey, and I can rotate the monkey like this. It's now a little off, so I'm just going to use R and 90 in order to rotate it. With Ctrl 2 I'm going to place a subsurf modifier, and also I'm going to shade the smooth. Now this would be the setup in Blender internal that we used and that I explained in the previous lesson. And if I now select the monkey and shift select the cube, in order for normal baking to work, you always need to check selected to active. I'm going to disable cage right now because we're going to have a look at that option later. If I disable cage, this text box here which says extrusion changes into ray distance, and let's just bake this. Okay, the result is kind of weird. We even get a hole in the back of the monkey, and this is where the normals are. Okay, I can see I put the monkey a little bit too far to the right, so let me just correct this. 0 and bake again. And you need to make sure that the baking object, or the object you want to bake to, is selected last. So there are a lot of error messages that can occur. And right now we can see there's the back of the monkey and there's the front of the monkey. And if we use the linked selection tool right here, we can check which face got what. So the face at the bottom of the cube got the face of the monkey. If I switch this to textured view, you can actually see that the face is at the bottom and the back of the head is at the top, including the little hole, which is not exactly what I want. This method is most suitable in Blender Internal, so if you want to surround your object with other objects which kind of imprint this like a stencil, then I'd strongly suggest use the Blender Internal, because in Cycles it's much more suitable to do basically the opposite. What I'm going to do is I'm going to place the monkey inside of the object, and then I'm going to select the monkey, shift select the object, then I'm going to bake again. And now we can see if I switch this to textured view, it did not update. Can't press Alt R because otherwise it would delete my image, so I'll just select it again. For some reason this doesn't update, so I'm just going to switch this to rendered view, the color to the color of the diffuse, and now you can see it's working this time, because you can see the monkey is looking down on this face, and if I choose rendered view, this face is getting the monkey while the face and this one is getting the back of the monkey's head. So this actually works a lot better. This is basically how Cycles intends to bake, whereas in Blender Internal you preferably put objects around the object you want to bake to and use them kind of as a stencil, while in Cycles you sort of model the high poly object and then use your low poly object you want to bake to surround it and then bake, let's call it, to the inside of your model. And to demonstrate this a little better, I'm going to use a chess piece that I have prepared for this tutorial. And this is the high poly chess piece that you saw earlier. You can see it has a multi-resolution modifier on it, and I sculpted a little on it. I'm going to push this to the side and activate my low poly. It has a subsurf modifier, but only with a subdivision of 2. So there's the difference. And now I'm going to select it, then press Alt G with this one as well, so they're exactly at the same position. And again, I need to select my high poly object first, then shift select my low poly object, and let's bake this. You can see I'm going to use the same material for this as I did for the monkey, except I'm going to cut this line by holding Ctrl and dragging across it. And since we're using the same material, the same image node is active, and we're going to bake to the same object. Now, all I need to do is press bake again. Of course, I took the liberty to unwrap this object so Blender would know where to bake to, and we can see this actually worked out pretty well. I'm going to go to layer 3 and let's switch to textured mode. Again, it did not update. It doesn't matter. I'm going to use the same trick again. I'm going to connect this to the color, and with Shift Z I can switch to render view very fast. Alright, this looks pretty good. Seems to be all in the right place. And I think we're ready to actually use the normal map as it was intended. And the correct way to do that is to insert a vector normal map and then collect the color to the color and the normal to the normal. Leave it at tangent space, and if you don't select anything here, it will choose the UV map that has the little camera enabled next to it. Just in case you have more than one, it'll use the default one. So I'm just going to leave this unselected just to show you that it works as well. And it's very important that you set the color mode to non-color data. Now if I render this, I'm going to turn around because this is where my sun is at. Alright, and you can see without the normal map, this looks like this. And if I use the normal map, you can see the imprints that I got from the high resolution object. Now, this looks pretty good already, but there is the cage option. And cage option wouldn't be there if it didn't serve any purpose. So let's find out what the purpose of the cage option is. I'm just going to turn this on, and can you tell us what happens and what the cage is good for?
Well, when you do it like this, then the Blender will create a virtual object from the object you're having now, and the virtual object, that's actually exactly like your object but inflated, scaled along the normals. It will be used to project, to serve as a direction of the protection. This will actually help you when you have these pieces around the crown of the king, because once they go up and once they go down, and by setting the direction correctly, the cage object will help you with this problem. So just try it and see for yourself. It will work out really fine.
Okay, I'm just going to press bake again, and let's have a look at the result. Now, you'll get the circular dependency error because the image is already influencing the normals of the object, and we're baking to an image that is supposed to influence the normals of the object. So that's a circular dependency. In Blender internal render, it would just refuse to work. In cycles, we can safely ignore this because it already baked before it created the error message. So now let's get to that cage option. By default, it's disabled. Let's just enable it, and what do you think will happen?
The cage option is actually creating a virtual object that is used to guide the rays. And by default, the extrusion is set to 0. When the extrusion is set to 0, we should see black parts whenever the two objects intersect. You're right now, exactly. And now let's try something different and set the extrusion to 5. This will also be interesting because now there should be still errors. And when you look closely around the crown, you see that the parts of the cross are actually creating dents inside the crown here. And that is because our cage object has become too big. And you should simply set this extrusion level to something between this part of the crown. So the distance between crown and cross, this should be the maximum amount you set the extrusion to. So if you set it like to 0.5, for example, I guess you would need to measure it, but try it with 0.5. Then we should get a good result. And what this cage actually is doing is like it's scaling along the normals, the object. So the virtual object is a copy of the low poly object scaled along the normals. This is an example where you can still work with the cage object, the virtual one, and the extrusion, but there are examples that are a little more difficult, and then you would need to model your own cage object, and that you could select below. There is a small thing, exactly. This is where you could select your cage model, and Frederik is going to show you how you create your own cage model.
Okay, so first let's try sort of a standard cage. The first thing that comes to mind, at least for me, would be a simple sphere around your object, and then the rays would be cast sort of inward from the cage object. And let's see what happens if I choose to do so. I'm going to select again the high poly first, the low poly last, and press bake. I get the error message, the circular dependency again, we can ignore that, but it says invalid cage object. The cage mesh must have the same number of faces as the active object. So what am I supposed to do with this error message?
Basically, you need to use the low poly object and create a cage from this. So you use the low poly object because that has the exact number of faces, and you use this to model your cage. Like, for example, select the low poly object, duplicate it, and then scale along the normals. That would be the simplest possible cache.
And to scale along the normals in Blender, let's first have a look what happens if I just press S. You can see, of course, the object leaves the original object. And this is not what we want at all. What we could do in this case is to click inside here, press period, or choose the pivot point to be the cursor and then scale, but still the object would not stay where it's supposed to. It would no longer surround the original object, which it is supposed to do. I'm going to rename this object to cage so it's easy to find it later on, and I'm going to go into edit mode, select everything, and then I'm going to press Alt S. I'm going to go into this mode, wireframe, so you can see better. Alt S, and then you can see I'm sort of blowing this up like a balloon. And in this case I have full control, and I don't have to guess how big the gap here is, because I can simply control it myself. Right now this would be an extrusion that would be too much. They intersect, and this is exactly what we saw when we set the extrusion to 5. And you can plainly see that with this method I have full control, and I can check if there are any gaps or overlapping parts of my object. For this to work, I obviously need to select the cage object, and then let's bake the high poly, shift select the low poly, and bake again. Now this doesn't really look different. So if the baking option without the cage apparently works very well, while if I use the cage and I have to either fiddle with the extrusion or create my own cage, then how come we actually have a cage object? Why do we have that option?
Maybe take a look at the rendered images and let's look at sharp corners and see how they are looking with cage and without. So obviously this is without cage. You see there are rendering artifacts. And now let's see how it's looking with cage on. And here you see it because the cage is also having like a kind of virtual edge split modifier, so it will respect sharper corners. But there is something else that's bothering me, and I mean, Frederik, you did sculpt on the other object. If we switch from cycles to Blender internal, there is an option to bake from multi-res. Why didn't you use that option, and what's the difference between using the cage object and everything instead of using bake from multi-res?
In our particular example, there's actually not that much of a difference, but if you imagine that you had created this object with a dynamic topology sculpt, so it's full of triangles, or that you'd need an even more low poly version of this, using again triangles for game, or just having a different geometry that you can't very well turn into the high poly object just using the multi-resolution modifier, then basically your last resort and only option would be to duplicate your low poly object, create the cage to let cycles know how to do this, and basically do the same thing as bake from multi-res, only with more freedom but basically the same amount of detail. If I look at the colors of the map we created from baking with this object, it doesn't really look like vector information. So how does Cycles convert the color map into vector information? Gottfried, talk me through that, please.
Well, for this, let me show you one pretty cool way to find out the direction of a face or to visualize it. And for that, I will set the shading to flat. Let's go to solid view on both of these. And this one I will give a new material. And it will be an emission material, so it will need a shader emission. And I want the color to be the direction of the face. And that is input texture coordinate. And there we have normal. And when I plug this in here and turn to rendered, you now see that each face has a different color. And the color basically corresponds to the direction of the face. So here you see is like the middle of the figure, and to the right we get a pinkish to a lot of red tones. That is because the x-axis, you see here, the red one is going to this direction. Then on the left side, there is no x because it is actually negative, so we don't see it. But we have some dark parts here, like the black parts here. And then on the other side here, we have a lot of green because this is where the wider axis is going. And on the bottom, we should have blue, yellow, and green because this is both yellow and green mixed. And there is no C, no blue, because that was going upwards, and there's only negative blue, which we don't see except for here in this dark black parts. Here we have negative color. And let me give this to this one as well. And now you might see the problem, and that is this looks not really like that.
And the reason for these are those dark black parts we got here, which I had shown you, which we can't have here because this is basically an image, a normal image in PNG, and that simply doesn't support negative colors. And that's why this image is normalized. And to use this as a representation of the direction of every face, we need to convert this. And there's another thing we need to do, and that is we need to set the shading to smooth, because now you see things are smoothed out and we don't have the direction of faces anymore, but of every shading point, because everything else, the directions get interpolated now. And now is the right time to add texture, image texture. And here I will simply select the normal. And then under vector normal map, connect those two and connect the output here to the input of the color. Didn't work. Now. And these things have changed a little bit here. And the reason is that the colors are different from the right, where we have the normal plugged in here, is simply because on the left I haven't selected non-color data. Once I select non-color data here, the image gets read correctly and they both look very similar. So here we got the one without the image, just the normals in the emission. And here we get the direction of every shading point, and on the left we get almost the same thing using an image texture and the normal map node. And this is the reason why we can get similar results when we are using the normal map compared to a simple diffuse material. Yep. And here to the left, let me simply show you it once again, adding the normal here, color here, and now they are very similar. And that's basically because it's the shading. The normal map will change the shading based on the pixel color here, and of course red is X, green is Y, and blue is C.
So the color information pretends that each shading point, which is basically sort of a pixel on a 3D object, has its own normal. And that is even exceeding the interpolated normals that you get if you set shading to smooth. Now let's have a final look at the shortcomings of normal maps, because if there were none, why would we ever need high poly objects? I've already mentioned it in the beginning. You can't see this imprint. Let's make a little more space here. There you can see the belt. The normal maps never change the outline of your image. They don't cast shadows, so we don't see the wave in the shadow as we see with a high poly object here. And of course, the biggest shortcoming would be over here, but that's impossible to be displayed by a normal because this is below the surface of the object here, and this one is above, so it can't poke through to both ends. This is a pretty extreme situation, which also explains why we have the very bright green colors over here, where Cycles tried to, well, do the best it could to solve this basically impossible combination. One final look over here. Normals are not that well suited with sharp corners, and sharp, I'd say, begins at an angle of about 100 degrees, but this is only counting for huge flat areas. So we have one flat area over here and one more or less flat area over here. If you just use the imprints or dents that we have down here, the angle doesn't matter at all. Just where your object has two fairly flat surfaces meeting, there you get, if you're unlucky, you get seams. We've shown you can minimize the seams by using the cage object, but down here it is even worse. So for objects that have very steep angles, normal maps are only suited when they are put into the background, but for faces of humans, skin, leather texture, all that stuff, that's very well suited also in the foreground. You you will hardly see the difference between a normal displacement or actual geometry. As you can see over here with a cross, that looks pretty much identical, and so does the weathering down here. That's it for this tutorial. From us at BlenderDiplom, thank you for watching, and if you've been watching this tutorial from YouTube, I've mentioned it in the beginning, maybe you wanna go ahead to BlenderDiplom.com, the link is below the video. There is a ton of information about normal maps, how they work in cycles in particular, and this information is part of our book, the Cycles Encyclopedia. Go ahead and check that out in our shop as well. You'll find a bunch of information about the book, including the table of contents and a few samples. This has been Frederik Steinmetz and Gottfried Hofman from BlenderDiplom.com. Thanks for watching.